Okay, so today for the iPhone application development course, aka Objective-C Introduction, aka, I don't know what you want to call it. What do we have on the menu this week? This week we have MontaView controller stuff. We've got GUI application development stuff. And as promised, a little bit more foundational stuff. So last couple weeks, well, we haven't had class for 2 weeks, but the last time we had class, we were going over bugs. There were some scary bugs that was built in a 3-part format that used a list view, and it used some controls, and I used it as sort of an attempt to discuss what the concept of model view controller with you. And in continuing with that format, I kind of want to emphasize a little bit of that as well. So that's the second part of today's lecture. But the first part, I'm going to go over some PowerPoints, lecture number 8, 9, and 10, that talk about graphic applications. And this is for Objective-C. So it's not 100% iPhone, but it's the same technique that would be used on a Mac application versus an iPhone application. It's the same technique. So, and it all works with the model view controller kind of thing. And this is really view oriented. And I'll discuss a little bit later, going back and I'll refresh your memory on the model view controller. But let me start out first by discussing the graphical user interface and graphics as associated with this type of development work. So the Coca class library, it is written in C, as we've seen so far. Actually, Objective-C is a dialect of C, as we've seen so far, and we can program in C as well. It provides classes for creating applications with GUI and graphics capabilities, written in native C, and capable at creating applications on the Mac as well as the iPhone. The packages are the same. So one of the advantages that you have in terms of learning how to do the iPhone stuff is you're also learning Mac development at the same time, which is kind of a cool thing. Essentials for graphics, we're looking at, and this is not OpenGL graphics. OpenGL graphics is also has some capabilities as well in terms of using that API. And that would be an API that was specific towards OpenGL. OpenGL works on the MacBook, it works on the iPhone, actually it works on Google Phone as well. It works on all sorts of different platforms, and there's a special API version for each one of those platforms. With the native, I'm going to call this native iPhone/Coca interface, what we're looking at is the event loop, which is kind of similar, which is why I mentioned OpenGL to begin with. It's kind of similar to the OpenGL event loop concept, if you're familiar with that. If you're not, don't worry about it. I'm going to talk about it in a few minutes. The most important classes are being the NS application, the NS window, the NS responder, the NS view, and the NS button, which are kind of, classes that you're going to use. You're going to make instances of these in practically every application that you create. And all programming depends heavily on the usage of object-oriented principles, obviously. Usage of Coca classes, derivations, and overriding of methods as well in terms of the interface. So this event loop is sort of like a state machine, which is sort of like the concept of event-driven programming in general, where you put a bunch of stuff out on the screen, and you instead of installing an event listener like what we do on the Android system, we actually attach listeners to GUI events. Instead, we just have an event loop, which is the listener that is looking for, did the user click on this list box? Did they change an item in the text field? What did they do? Which gives us our event-driven behavior from the GUI. So it's all, believe it or not, it's actually more automated and integrated on the iPhone versus some of the other development environments for mobile devices. But the event loop itself is sort of the foundation for the event-driven behavior that's occurring. It all really starts with the NS application. So this class represents the event loop. So the application is the event loop. So we don't actually create, we don't install a listener and set a listener and set the listener to listen on a button, which is what we do in the Android environment. Instead, we present a instance of an NS application, which gives us the event loop, which is the main body. It creates the loop, it starts the loop, it stops the loop. So NS application is really in charge of the events, in charge of the interface itself. NS window runs in the NS application. So you might think of this sort of as a hierarchy, if you think about it in concept. We have the event loop is the outer package, packet object, let's call it that, and then inside, if we nest inside an application, we could put a window, and in a window we got a respond, and we got a view, we got a button, we got all sorts of different things in terms of the levels of abstraction, if you wanted to take it to a more abstract kind of level. So past the NS application, we have the NS window. It initializes windows with various different window parameters, and the window is a window. It's the same as MFC, Microsoft Foundation class kind of development, but it's completely rewritten, and it's completely different in terms of programming style as well. There's an entire structure to the NS window. We have a frame view, a content view, and we've seen some of these views already. The bugs had a list view. When we had the scary bugs, we loaded them into a list view, and we were able to put icons in the list view as well as text descriptions and all sorts of different things. And the view ends up being the view. And the view, in essence, from our model view controller, is our user interface. So it's kind of it's a little different, I guess, in terms of the philosophy of views versus UI. You know, in traditional application development, people used to create user interfaces. They had screens, like login screen, password screen, main menu, all these different kind of things. Well, you still have that hierarchy of screens, but instead of really calling it a screen, you're looking at a mobile device. It's kind of small. You're looking at views at that point, and the view is in the context of the information of the model, for which, and the model is really the data. The model of the application is the data component of it that's presented through the view with the underlying controller, and the underlying controller is the navigation. It's the button press, it's the scroll, it's the zoom in, the zoom out. If you press this button here, it takes you to that view over there. That's the controller behavior that's going on within that particular perspective. So if you really think in mobile device contexts, the view is the window, which is the application in terms of the hierarchy. So we have frame view, context view, list view, all sorts of different types of views that might be associated with the UI. And we switch the views around for different parts of the application. So this concept of the callbacks and callback in general is another foundational concept associated with it that I've talked a little bit about before, but to refresh your memory on the concept and bring it together with the UI elements. Callbacks are methods that are not called through the code of the programmer, but through the events created by the user of the application by the runtime system. So going back to that event loop kind of concept, it's callback driven. It's from the event of clicking on the button, opening up the something or other, the file folder, typing in a text box or something produces a callback. And so all the callbacks are provided through the class RS_responder. The NS responder, is the mechanism for dealing with, it's equivalent to the listener plus the action that would happen on a particular GUI element once it was executed, or once something happened and changed with it. So it supports the NS and the NS view and the NS window. So we can put many views inside of many windows. We can have one window switch the views. They're independent components and they're nested in a hierarchy in terms of the interface. So callbacks are added to programs by ultimately deriving from NS responder, overriding the inherited callback method and using the derived class in the code, essentially, in terms of the concept. So, in one of these days, I'm going to put all these lectures into one, but they're split out into smaller. There's 3 that really should be put into one. This is number 9, or part 2 of the first one, which is most important GUI elements. And we've seen these already, so this is sort of the lecture part of some of the code stuff that I've already previewed for you. And the preview was in the form of that scary bugs program. And I gave you the links for that, so hopefully you're putting that together. And if you did come in late, the assignments link seems to be missing from everywhere, so it will be fixed by next week, and next week I'll be going over the assignments that will be due for the course. I know that there's 5 of them, that's all I know. Where they are, I have no idea. I had them at one point. They're gone. So anyway, you'll be able to implement some of the views, the buttons, the windows, and stuff in your assignments. So windows, views, and buttons. So the NS window, continuation from what we just looked at a few minutes ago, every graphic application needs at least one window. In fact, if you open up the UI designer, look at it, you get a window. Whether you want a window or not, you got a window. So it's the default. It's main. It's the default kind of program. You cannot draw in windows, but you can draw in views, and you can put a view in a window. So you put the view in the window and you draw in the view. The window contains a content view, and we can add subviews to the content view. So as the main structure, the content view is the outer housing for this other views that we can nest inside of it. And then we put the content view inside of the window in terms of the abstraction. So the NS view, so a view can be put in the window by means of a content view. The view can have any number of subviews associated with it, and the subview of a view will never expand beyond the range of the superview. Superview. It's like when you created frames with HTML, you create a box, and inside the box, you can't make the view any bigger than that box, essentially. It's stuck, which is not a big issue. It just means it's a great way of nesting and hierarchying the interface so that certain things don't expand or go past the boundaries that they're supposed to go past. So it makes for a nice, clean interface. Slightly different concept actually in Android, because we have the different types of layouts, and then in the layouts we put components. But we can actually put layouts inside of layouts as well, in terms of if you're taking the Android class and you want to relate it back to the Android concept. The layout is the view, in essence, and the window is the window. It's the main window. Done in a lot different format. The same hierarchical nesting exists, actually. You can put views inside of views, and you can put layouts inside of layouts and stuff. So views that are siblings do not overlap if they're siblings, and because the sequence in because the sequence in which the siblings are displayed is undetermined, so they can't. So they're separated out into sibling from different perspectives. The buttons. So outside of a view, most of the apps are going to have some sort of a button of some sort, whether it be an image button, a regular button. They come in different shapes and formats, and so do the views actually as well. These are generic concepts. The NS button is derived from NS view. It inherits all of the methods of the NS view and can be added. It can be added to a view, obviously, and can be initialized like a view. Anything that a view can do, a button can do. So it's nested inside just like another view. Basically holds the same order of precedence in terms of nesting or hierarchy. There are special methods that are initialized for buttons, setting actions on buttons, setting images on buttons, all sorts of different things, properties, if you want to call them that, or initializations. And there are several ways of adding callbacks to buttons. We have a target action, a design pattern that's associated with it. So actually, there's a lot of design patterns. Model view controller is a design pattern. There's a lot of design patterns that go with iPhone development, and it's only because, if you think about it, it's purely object-oriented. There's a lot of design patterns to object orientation. So it basically utilizes a lot of the different object-oriented concepts in terms of the interface and the workings. The NS responder is the one that keeps, pays attention to what's going on and then responds to events when they occur. So the NS window, the NS view, NS application, they're all derived from NS responder. If they come from the same hierarchy, then they have the same behavioral control. Responder contains all important event messages that the application might need. So you can make your own application respond to these events by overriding the inherited event message. So when something happens, you can overwrite the behavior, have something else happen, change the characteristics or change the behavioral patterns. The application delegate, we've seen it in practice, but here's the foundational kind of description of what this really is supposed to be standing for, what it's representing. So if you wish, you can write a class that implements the NS application delegate protocol. Don't have to, it's actually optional. if we add an object of this class as a delegate to an NS application, then we implement the methods. Will be called at certain points during the running of the application. It's part of the automated loop. It's part of the event loop, which gives it a place, I should say, in the hierarchy. Gives it an appropriate recognition in terms of where it ends up in terms of the execution of the program. Versus, any class that you create that you put in there is going to be a different. It's naming convention, but it's a different convention. I mean, it's a different meaning behind it. So it's going to look for it in terms of the automatic event loop that occurs. So you can do anything you wish inside of these methods, but they serve mainly to structure the application code and customize the behavior of the application. There's a lot of people that just use the application delegate and don't create any other extra classes. If you're creating a simple hello world program, which hopefully you've done so far, you're editing application delegate. It's kind of like the equivalence to the Android main activity. So it's the activity file, application delegate file. It's like the equivalence in terms of the activity class that gets created. Methods can do anything you want, actually. The program can do anything it wants. There's no restriction on that. Same way there's no restriction on an Android activity class either. You're just inheriting, and from an Android perspective, you're inheriting from activity, or if we saw earlier today, map activity. And in an iPhone world, you're inheriting from NS object, and the application delegate is just like saying main in a C program. It's the main program. It's the starting point. So you're going to add more classes to it if you want as well. So the target action pattern. This pattern makes Cocoa graphics programming very easy and powerful. It's the target action. It's the pattern that associates with functionality given to buttons, given to GUI items, outside of buttons, anything actually in terms of event responding. So any method of any object can be made into a callback for a button click or for other GUI events. So it's flexible in terms of the methods for different objects. Actions and targets can be changed dynamically or at runtime. At runtime dynamically, or they can be set statically before the program actually does execute. Programming examples in the lecture will make this clear. Well, actually, I'm going to show you the examples next week, but because we have too much lecture stuff to go over this week. But I'll have some examples coming up, and I'll point out this is the target action. In fact, we've seen the target action already in terms of clicking on a button or pressing on a button. The target action was to open up a separate view, and the view showed a detailed view of the bugs, which is what the target action was all about. Number 10. Oops. There we go. Part 3 of GUI. So, using the interface builder to create Mac applications. So, the interesting thing is, as you're learning iPhone interface building and iPhone applications, you're actually doing Mac development as well at the same time. You're doing Cocoa development. So you can do the same thing for a Mac application as you're doing for an iPhone or an iPad application, which is killing a couple birds with one stone if you think about it. In fact, it's all integrated into one, which is why a lot of people actually kind of take this route in terms of learning objective, because you can learn multiple different platforms all at once. So what do you learn with the Android? Well, you learn Android. Well, there's a lot of different platforms on the Android as well, though. So pretty soon they're saying, actually, a side comment, they're saying pretty soon that there might be some Android, desktop. Well, there are some. Some of the EPCs have Android written on them instead of Windows. I'd love to see Android take over Windows, actually. Get rid of Windows completely. And just have Android operating systems. It's such a much better interface, if you think about it. So, of course, there's no .NET. And there's no Microsoft. Yeah, I'm not a huge fan, so I'm not going to miss anything. So, anyway, basic starting sequence. We know this already because we've seen it in iPhone development, but just to review the concept, if you were going to relate it to Mac OSX application development, we start Xcode, we choose a new Xcode project, choose OSX application, or choose iPhone. It's going to be the same essential toolkit and the same essential approach. However, the binaries are different because it's running on two separate operating systems, running on a portable iOS versus the main one. Choose an icon for a Cocoa application. We actually have to manually give ourselves an icon on the iPhone route, name the application, set its location, and then after clicking on Save, the Xcode IDE brings it up. So it's brought up, contains runnable minimal application, a hello world application. So we get the same effect though. So in a Coca environment for OSX, we have a minimum application that's hello world, just the same way as we have a minimum application on the iPhone. It presents a starting code, contains an NS window, but the NS window is actually for Coca interface instead of the iPhone. So slightly different, but very similar. To see it running, you click on the build and you click on the run. You start using the IB, double click on the file, the XIB. So we still have the same XIB file. We still have the same kind of layout in terms of the development. So, and the reason why I'm showing this to you is because you can hopefully transition one back way from iPhone to OSX development, and then from OSX back to iPhone. You know, hopefully it's the same. It's the same language. It's all in Objective-C or C, it's all using the same toolkit. It's all using Xcode. So it's not a bad transfer of skill sets to one operating system to another. And we have the interface builder, same thing that we have for the iPhone, we have actually for the OSX platform in terms of the interface. Upon starting, the IB presents, the interface builder presents the application window as it currently looks, the main XIB window, and a menu bar for the application. So just a generic menu bar that shows up for an application. We don't get the menu bar on an iPhone application. Actually, we just get the window and it says Hello World or something like that in it. So, in terms of working with the interface builders, we've seen so far adding GUI items to it. In the iPhone, we have a library. We open it up. We can drag and drop. And we've seen it already. Text boxes and labels and things to the window. And we can actually connect those items with class elements that we've created. And we've seen a program that actually does that already, where we've created a class, created some functionality, some actions for the class, and then we've connected the actions to the GUI. So not so different than OSX actually. So open the library window in the IB, drag and drop some items to a canvas, except for the Windows Mac application instead of an iPhone application. So it's the same thing. From objects or classes, tabs, you can drag various different GUI elements to the window, release them. IB will automatically create the corresponding GUI object for you and present it. So if an item is not suitable to be in the window, dragging will simply not work. Actually, that's the same thing you're going to find with the iPhone development. If you try to drag an item from the library to the window and it's not supposed to be on that window, it's like a menu or something, or it's something that doesn't go that way, it just doesn't work. It just doesn't give you any message. Which, comparing it to the Android environment, Android actually just gives you a bunch of messages. I hate, it's like, does someone ever always want to tell you something's wrong with it? Like those irritating Eclipse red boxes that appear next to your project constantly when something is wrong, something is wrong, something is always wrong on an Android. And on an iPhone, it just doesn't work. It just doesn't work. It just doesn't work. It's never wrong. It just doesn't work. So it's a little different in terms of the API and the way that the structure, the environment feedback, I should say. The developer feedback is a lot different between the two different APIs. So working with the interface builder, we can resize and position the GUI items themselves. All the GUI items in the window can graphically be positioned and resized, can be even given color in certain frames and text and pictures. And we've seen that already with the properties box when we bring up I call it a properties, I believe it's probably called an information box, where we have the different tabs, and the different tabs are going to give us the GUI element components themselves, what's visible, what's not visible, the names on the components, and then some of the file, or graphic attributes that are associated with it. Color, foreground color, background color, different things are associated with it. Save, we can save the items, and additions and changes will be saved to the interface builder by typing in the command S while focused on the IB window. Lots of the other interesting thing about iPhone development, which is kind of a little bit different, is there's a lot of command keys, key combinations for saving, for opening, for doing stuff. Or you can also choose the menu items themselves as well. And you don't have that in Eclipse for the Android environment. You do. You have function keys that work on that. but not so many command key combinations. Quitting the interface builder, you can use the the command Q while focused in the IB window. If you don't save, this is the other interesting thing that I have run into occasionally, is if you don't save the interface builder window and you leave it open and you run the app, it doesn't save it automatically. You get the old saved version when you run the iPhone app or the Coca app or program itself. So you actually have to remember, so I get in the habit of just saving and closing the interface builder once I've made a change. So, adding behavior to the GUI items. In terms of an example of working with the interface builder, all GUI items have a predetermined behavior that corresponds to the item. As an example, the text field will allow text to be typed into it, changed, edited. The button will have change colors when it's clicked. Have that clicked look, the unclicked look. I don't even know what that means actually. Does a button actually change color? I don't think so. The button looks like it's been pressed though, doesn't it? Buttons have that look sometimes. Maybe it's just changes in colors, like it looks like it's depressed. I guess if you have a 3D button, when you press it, it goes in. There's a button supposed to go in, right? And the links, when you click them, when you press on the links, they're supposed to change colors and stuff. That actually gives for a nice user experience if you design it correctly. You could design it counterintuitively, though. Make the links change when you don't click on them. So. So if you like the default behavior, good. However, we always want additional behavior to exist as well. That is determined by the logic of the application. For example, the text typed into the text field should be analyzed by your program code. Certain actions should follow in terms of on a text change or something. When you click on the button, you should start some other program or some other application that might run as a result. And that would be considered part of the action that's associated with the button in terms of the events from the event loop. So in terms of adding behavior, basically you need to do two things when you add behavior. You must, in your code, have a reference to those GUI items that are intended to be triggered actions in your code and those data that you want to use with the particular action. And we've actually seen this already. So what I'm doing is kind of describing in terms of the foundational kind of material stuff that we've seen in terms of adding, even when you created Hello World as an example and you put a button out there, you still had to tell the application delegate that there was a button. And then here's an action that goes with that button. And then here's what happens. And then you connect the action to the button in the interface builder. And then when the program runs, button. I know about this button. Here's the action that's associated with it. And you're pretty much just connecting the dots, essentially, in terms of the behavior. So you have to tell your code that there's a reference to the GUI, and then you must program those actions and set them to be called when the user event happens. So mouse click typing. So what we're doing is we're just creating the GUI items. We're telling the code about the GUI items, and we're creating the actions for the GUI items. Voila, we put the pieces together and all of a sudden we have a working component. So when establishing a reference to the GUI item, we create a reference of the same type as the GUI item in your code. So if your GUI item is text field, we have a create a NS, can we have that basketball stop? We have a create an NS text field with an asterisk in the application code. So where in the code does that actually go? So it must be inside the class that knows about the interface builder. So actually it can go in any one of the classes. So it has nothing to do with the GUI item itself. It's where it's graphically located. It just has to go into the class that's actually going to use it. So here's an example. So you can put in an NS window class because your application does not have an NS window code. On the other hand, you could put it in an app delegate class because, as you can see from the class list in the main menu XIB window, that app delegate is available because it's the main program or main class of the application. So, or you could put your class in your own, you could put it in your own class and add it to the IB essentially, interface builder. So. We actually have done that. If you watch the first video that did a Hello World with inputs, I created a separate class put the action inside of the class, added the class to the interface builder, drew it from the interface builder, and then dragged it over, the actions over to the items to connect the functionality. So that's actually been demonstrated already. So in terms of establishing a reference to a GUI item, more options you can do. As an example, you have an application named ABC. You could place the line IB outlet text field asterisk TF1, text field 1 is the name, in the ABC app delegate class to declare the reference. So we decide that we're going to declare this reference to this GUI element, open up the inspector window on the connections, and then connect it. So highlight the ABC delegate class in the main XIB window because the reference is in the class, drag it over. So the identifier will show up in the listing of the outlets and in the connections inspector. And the connection inspector is inside of that box I keep calling the properties window, which is the information box. So you click on the item, you click on this other information box, it opens up. One of the tabs is the connections inspector, and it usually has like a chain or it's either a chain or it has an arrow. It has some sort of a symbol that doesn't look like what it's supposed to do, and it's used to establish the connections between the programmable item as it's referenced in the code and the GUI item as it's referenced on the screen. Why they didn't make that together, which is kind of interesting, but if you think of the concept, going back and comparing it to the Android platform, it's the same thing. You know, you build it on an XML interface, you put items out there, but still in the code, you've got to, either implode it, or extract it, or go to the layout and say, hey, from the resource, give me everything that's on main, give me everything that's on this resource, and then you're calling it by the GUI item label that you've given it. So it's really kind of similar concept, but in the iPhone development, it's done by a drag and a drop, if you want to do it that way, where you don't really have that capability in an Android environment. You can't drag and drop the GUI item to the corresponding activity that's associated with it. And then also in the Android, you have a listener, an event listener, which you don't have in an Android, in an iPhone environment. Well, you do have it, but it's manual. In an Android, it's automatic in an iPhone. So establishing a reference with the GUI control, here's the, we've seen this actually already, but here's a review, just in case you've missed this lecture. And this is what I'm calling this properties box. I don't know what they really call it, information box. And I believe it's the arrow tab here. Older versions had like a chain. Looks like two links of a chain, because what you're doing is it's connecting. You're connecting one to the other. But I guess the arrow makes sense because when you actually click on it and drag it, it turns into an arrow. It's a blue arrow. So I don't know. People that design this GUI interface get kind of creative. So below is the ABC window, and we put a text box on the ABC window, and with the connections inspector. Before and after the connection is made, you can see we've got the app delegate file owner, we got the window, and we have this up here, we have this empty box, and it says TF1, which is the name that we gave it in this previous slide here. It's an IB outlet text field, meaning it's from the interface builder. It's an outlet. It's going to be the text box, and this is just a generic word for GUI item. It's going to be a text field, and the text field is going to be a pointer to TF1, which is the name of the text field. So down here we say, well, what is this text field? Well, the text field is this text field. So if you can see down here, after we've dragged it, we can see that the before it was empty, and we have the window that's ABC window, and that's about it, right? So for this outlet, what we've done is, in fact, we've connected it to text field, and the text field is this text field up here. And the way that was done was a simple drag and a drop. So the connector, you would simply actually click on this. I can't click on it because the slide's going to change on me, but you click on it, you drag it over, and you see this blue line with an arrow, and you put it on top of this text box, or you put it on top of this text box, depending on which window you're in, and the connection is established for you automatically. You could do it that way, or you could do it programmatically. But But this is the most preferred way. And actually in the first couple of APIs that were out, it was all keyboard controlled. Now it's mouse controlled, which is nice. I believe you can still use keyboards though, keyboard actions to connect it. But usually the mouse is more intuitive. And so this is sort of, for those of you who have been attending, we've seen this live as well. So you hopefully have connected the dots at this point, or connected the components, the outlets to the code. So adding an action to the GUI item, we can write the code as a method of any one of the classes and that the interface builder knows about. For example, the app delegate or any class of our own making that you can make known to the interface builder. Well, how do you make it known? You just stick it in the same class folder. So if whatever you put in the app delegate folder, which is the class folder, object folder, it's going to be seen in the interface builder. So in one of the examples, actually, I made a separate class, and I stuck all of the actions in that separate class. And you have to excuse me, I have a little bit of a throat issue right now. Getting over a cold, and my throat's not agreeing with me right now. Let me just take a drink of water. That might help. Ah, much better. You ever get that little scratchiness that just makes your eyes water? That's what's going on right now. Except for the eyes aren't watering because I'm too dehydrated. Anyway, so we have this folder of objects that we've created, and if you don't want to keep using that app delegate, you don't actually have to. Anything you put in there will be recognized by the interface builder, and if it's recognized, then you can actually drag the actions from that class. And we've seen that actually in one of the examples. So if you missed it, go back and take a look at the first Hello World. I create a class and I do just that, so you can actually kind of see that working. And then you want to click on the GUI item in the application window, whose action you want to set to, and then you open up the connection inspector and you drop it, which is essentially what I described for you in the last slide. So under the sent actions list, you'll see the selector for that particular item. Click on the empty circle, drag it to the window itself, to the item, release it, and the automatic connection is created. So upon releasing a listing of all of the implemented methods that can serve as an action for that one is going to be shown. Basically, you see it shown in the end. So adding an action to the GUI item to continue with the process. So the process, what this whole thing is actually describing, corresponds to the target action pattern. That design pattern, as I kind of mentioned before, it's like taking the target and associating it. The target is the GUI item. The action is the method that you created that's performing the functionality that's going to happen when that GUI item is selected. And the GUI item selection in terms of the target, you might have, and not shown in this picture here, is if we had, let's say, a box, or we had something where, down here on the bottom where it says text field, let's say that was a button or something. It could be, or a mouse click or something. It could be, was it a right mouse click, a left mouse click? Was it entered into the item? Was it entered out of the item? Was it a click, a double click, a single click? All of the different behaviors associated with it can all be performing different actions. And if that were the case, we would have different actions associated with the targets. And we can simply assign them, and then we would have the appropriate behavior occurring on the appropriate action. So it's really referred to as a design pattern. So the target action pattern that we used in writing the app without an interface builder, the action method must be written with one parameter of a type ID, and the type ID is the corresponding type of associated action and GUI item, so we can essentially connect them together. These are the elementary steps of using the interface builder. There's obviously more to it because there's so many different types of GUI items that can be taken from the library. And there's also different types of nesting that can occur as well in terms of some of the windows inside of windows and controls inside of the windows, etc. and so forth. So it's basically just a rough overview of the, let's call it the textbook material for the examples that we've been seeing so far. Now, one of the other things, and this actually comes from a guy who's done a lecture over at Stanford, actually, and I sort of found this online along with, and it was referenced from the bug example. So if you were here for the scary bugs, the reason why I was kind of showing you that scary bug was because I was trying to find a way of introducing the model view controller to you, because it really is the foundational design pattern for a lot of iPhone and a lot of GUI, a lot of object-oriented application development these days. And the interesting thing is I kind of ran across this lecture and I sort of liked the way, and I'm going to skip through all of it, and I'm just kind of showing you these. There's a couple of pictures in here that I kind of want to pinpoint to. Because he really does, this guy really does, we'll give him proper credit here. He is, this is from a class taught in 2011, it's only about a year ago, on an older API, developing applications at Stanford, actually. And Stanford's actually really pretty good. They make all of their course materials. In fact, you can take an online course for free in iPhone development at Stanford, actually. Just go to their website and look for it, or search on online, free online class. And this is actually from I don't know if it's from the free version of it or from another version of it, but anyway, long story short, it was made freely available, so I thought I'd give credit where credit is due. This is not my slide set. However, he does a really good job putting the pieces together, which is the reason why I'm using this, in terms of the model view controller. So when we made that bugs application, scary bugs application, it was a classic example of that model view controller. So MVC, excuse me. That's what I needed to do. I just needed to cough. Okay. The model is the data. The view is the window. The controller is the action, or is the logic behind the action. So if you think of the application in terms of those three components, that's the entire application. And if you model the application, then you can model the views and the controllers per the views and the persistence of the data, and you can essentially come up with a fairly sophisticated, well-organized design pattern that works quite well for object orientation. Anyway, this guy, when he teaches this class, he actually uses this 100%. It's just one design pattern, however, and I don't really believe that, it's necessary to use it 100% of the time. However, it's not a bad idea to know about it. And so, since I sort of went on that route with the Scary Bugs program, I thought maybe I would recap and use today as an opportunity to kind of summarize what this design methodology was all about. And then next week we'll see a totally different design methodology. We'll take it, to a different level. So hopefully at this point you can sort of see the basics of it in terms of handling the UI view controller. The UI view controller class was what we actually did. We created a UI view controller with the Scary Bugs. And it was a subclass of grouping that provided the control over what happened when a user clicked on a list item. And the list view and the view was actually a separate class, a separate object that was created. And the view controller worked with the list view, so that when we clicked on a bug, as an example, it opened up another window, gave us a description of the bug. We could change the picture. We could add a new bug. We had a bunch of different control over that entire GUI item. And it was UI independent because the controller would work for any bug, any list view in terms of the design pattern that was created. So if you've got that, then you've got reusable components that you could put together. So anytime you had a list view, you just pull out the view controller for the list. And again, you're not reinventing the wheel, you're just using a pattern of functionality that you've created already. So what happens when your application gets more features? Well, his concept is, now that you have a UI, you can't fit one in one model view controller's view, you just create more. So you follow the pattern of the separate view, separate controller, separate data model. You create two. So this was one. This is why I like the slides. I like the pictures, actually. I can't draw these pictures. Now you have two. So what is two? Well, one of them is a different feature. So if you think of the concept, then you can break out the functionality and kind of, it's almost like an outline if you think about it, because you have the main view and you have your subviews. Each one of your subviews has a sub-controller and a sub-model to it. And then you could share components among the different views. There's no, like, it's not mutually exclusive. Like, just because something was from this controller doesn't mean that controller can't control it as well, or can't do something with it. So you can subdivide it, yet keep it together. So you'll never have a model view control view span across screens, if you think of it. As an example, if we wanted to have scary bugs be scary bugs and animals, we could have scary bugs on one side and then animals, and then we can have birds and dogs and cats and scary everything. When you're editing a scary dog, there's no need to look at the bugs. It's a totally separate concept. So you're never going to have the view, you're never going to want to view a bug. So if you separate it out kind of like, and these are the three components, the model view and the controller, per functionality in the UI, it provides a nice, easy to understand abstraction for developing and future growth of that application. So it's very, long story short, it's very expandable and it's less confusing. And it's almost like having 3 or 4 different smaller applications in your bigger application. It's kind of like modularization, or the equivalent to modularization. So when you're developing an object-oriented program, or any program actually, and you're dividing it out, and you want to, let's say you want to build an accounting program. If you built a payables module and a receivables module and a reports module, when people are using and you're designing the reports module, you may not necessarily be dealing with accounts payable or receivable. I don't know anything about accounting, but I know that those are separate functionalities. So if you're creating modules or components, then they're exchangeable, which means if something happens with the reporting, you don't like the features of the reporting, you could put in a new reporting module. You could stick in a brand new reports module or something, which is flexible, expandable, growable. So if you kind of use that same design, and it's really equivalent to this abstraction of creating separate modules, but these modules are combinations of 3 components, the model, the view, and the controller, that's being kept separate in modules. You're loading the modules all together, so your programs can actually share components over time, because one reports module could be used in 5 different programs. And let's say it's a GPS mapping program or something, and you could create the functionality once and reuse it in every application your company distributes. It's all the same functionality, but it's just put in terms of its set of model view controllers. It's put in as a separate resource, separate application. So you create a new model view controller for each one of the new features that you create for the application, essentially. So scary bugs can be scary dogs and scary horses and everything else. So how do you switch the screens to show the other model view controllers? Which within the controlling. So the model view controllers are working together. We use the controller of the controllers to do that. So for example, we have a navigation controller. So if you have an accounting program that has accounts receivable, accounts payable, reports, and all these other little things, you have another controller of the controllers that comes through and says, well, the user selected this item. Well, that's from this module. That's in the payables module. So the payables module functionality starts working. Or they selected that feature over there. Well, it's from a different module. So you have a controller for the controllers, essentially, which is the design philosophy. And the window is sometimes the controller for the controllers. So you could create the GUI components, actually, to control the sub-components in terms of the hierarchy. And this is kind of like how all these pieces sort of fit together. The navigation controller is controlling the separate model view controllers that we're putting together in sets. So with all the pieces working together, the controller's view would sort of look like this. It would have you know, the navigation controller, which might have major buttons, smaller list views or something. And then inside of each one of those would be the smaller model views of the controllers that would be part of the subsystem. Anyway, if you're interested in this, I could post a link. Actually, I'm not going to go through the whole thing, but I sort of wanted to bring up the concept in terms of showing you the concept of all of the sub-pieces working together and the modularization that can occur using the model view controller. So in here we've set a root view controller outlet to another controller. So it kind of grew on itself. So we had a regular navigation controller. The navigation controller picked up a root view controller. The root view, I mean, we're just taking it to another hierarchy at this point for the navigation controller. And then it works with the view controllers. So essentially what you're doing is creating a hierarchy of model view controllers through other controllers. So anyway, it's kind of interesting. I don't really follow and I don't really agree with all of the design methodology. And this is not set in stone. Like, you don't have to use this philosophy. But it's very popular in terms of design techniques or design patterns. And the bugs actually follow this. They follow this pattern. It doesn't go past a hierarchy. It's only one model view controller in the Scary Bugs application. But if you follow, if you missed it and you looked at that video, the Scary Bugs follow the model view controller design. So. All right. My voice is not holding out. I'm actually going to call it quits because we're gonna have a short class today because this has been a struggle. So what I'm gonna do for you though is what have I got here? No, I'm not gonna start in on anything new. What I'm gonna do is stop this for today. Next time we'll try to go a little bit longer, make up for what we missed today. And I want to go over the assignments for you. We are about halfway through the course, and let me just pull up the syllabus real quick, actually. Just to refresh my memory. Let's see. We do have 5 assignments. Yeah, we don't have a midterm for this course. We have a CSLO essay. The CSLO essay for this course is going to be a writing assignment. It's probably like a little bit of a research, not a programming one. We do have 5 assignments that they've disappeared somehow from the bhacker.com and also from the ITU LMS. So I'm going to go I actually have found them. I'm going to go put them back. So on the agenda for next week, what we're going to do is start going over the assignments that are going to be due. And after I've been giving you a lot of examples, I gave you some of the foundational text material today for the examples. What I'm going to do is start adding in with more examples next week as well. So, and then getting those posted as well because they're not posted yet. So next week we'll go over the assignments, and I might actually even have the CSLO essay for you available at that time as well. We'll do a little housekeeping with that. And then we'll start in with some more examples. And what I really want to start doing now that I've introduced, and you should have probably a pretty good idea about the programming environment at this point, the interface builder, the classes, the model view controller, a lot of the foundational material for application development. And what we need to start doing now is just jumping into different applications and seeing how the features work. And I'm trying to gear those towards the assignments, so we'll bring that together next week. So we'll have a short class today. Now that I can breathe again. Huh. It comes and goes. Like a few minutes ago I couldn't breathe. Now I can breathe. Oh, that's all right. We're done. We're done. I'm not going to start. So see you next week when I can breathe. Uh-oh. Stop capture. What's the difference between stop capture and abort capture? I think I just lost my video. No.